Hey, what's up, everybody? Welcome to our 11th of 12 Mountain States Concrete Pipe Academy webinars. This is the one for November. Obviously, we're going to be talking about precast box culvert design. I'm really grateful that we have Mr. Mike Blackham, a professional engineer up in Idaho. That I've known Mike for many years. He works with Geneva Pipe and Precast, and so we're grateful to have him here. Thank you so much, Mike, for offering your time and being willing to share this message with us today. We definitely appreciate it. Just a reminder that we have any Academy webinars that we've done all throughout the year, so the previous 10 are available on our website at mountainstates.concretepipe.org. You just click on the Academy tab and you can go down and view any of the previous webinars that we've had, and they're all eligible for one PDH. So those will be available until the end of the year, and then we will we'll pull all those videos and put them like on our YouTube channel or something, but we won't be able to give you PDHs after they're just viewable on the YouTube. So make sure you get those done by the end of the year. So we've got a hard stop at 1 o'clock today, so we've got to go through this real quick. So I'm not going to spend any more time. I'm just going to turn the time over to Mike. And again, Mike, thank you so much for offering to help us out today. I appreciate it.
Yeah, thank you, Jason. I appreciate it. Happy Friday, everyone. Can't believe it's already towards the middle of November. How time flies. Just a little bit about myself for those of you that maybe have not met me. I've been in the precast industry for over 16 years now. As Jason has mentioned, I've worked with him for a long time. I've worked in Idaho, Utah, Wyoming, Montana, all in the Pacific Northwest. So box culvert is something I'm very, very passionate about. I've probably been involved with over 200 box culvert projects over the years. That's probably on the low end. And as mentioned, in probably 9 or 10 states, most of the DOTs here in the Northwest. I've gone as small as 1 foot by 6 inch little trench box culverts up to 28 foot by 20 box culvert. So I've kind of seen a large variety of products, and I really think box culverts are pretty awesome. So getting into it, the agenda a little bit. We're going to look at some applications for box culvert. We will talk a little bit about box culvert basics, and depending on the audience and how much experience you all have, we might fly through the 101 of box culvert, or we might spend a little bit more time on it. We'll just kind of see here in a minute. We will talk about design and specifications. We will also talk a little bit about how to detail out your plans and what to look for and what to give contractors. We'll then hit on installation a little bit, and last but not least, talk about the precast advantages. As just mentioned, I've really been involved a lot with box culverts, but there was one box culvert project in particular that it really made me smile, and it means a lot to me because I know Mr. Jason Allen, how much it means to him too. And that was a project once where I caught Jason meditating inside a box culvert, and just happy as can be. As you can see, he's just lit up, and man, he's excited. So I don't know if you remember that or not, Jason, but that was a good time.
That there's really nowhere better to meditate than in the middle of a box culvert. and actually, while they're trying to install it around you is usually the better place. So any engineers out there that really want to get a good meditation when someone's trying to install a box, just go climb down in there and meditate. It's great. You gotta wear a tank top and shorts though. That's the rule.
That's right. So there you go. I think with that being said, I believe we have a poll question.
Absolutely. We want to gauge who's on the call here, so we're just going to launch this poll. Just a quick yes or no, so we could see, how many of you have been involved in the design of box culverts here. So I'll launch that now. Have you ever designed or specified a concrete box culvert? Yes or no? If you're in full screen mode, you may have to minimize out of full screen mode so that you can vote. But I just wanted to see how many of us have been involved in specifying or designing a box culvert. All right, we'll give you about 5 more seconds. Almost everybody's voted here. So 5, 4, 3, 2, 1, we'll close it out and we'll share that. So it looks like a majority, Mike, about 60% have designed or specified a concrete box culvert, and about 40% said no. So this is kind of a good grouping, almost half and half. So we'll be able to kind of take a look and see, go over the basics with them. So that's good. Good to know.
Great. Yeah, that's great information. We'll spend a little bit of time on it, and maybe there will be something even the people that have designed one will learn here. But okay, so first of all, what are some of the applications we can use box culverts for? There are many, 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 but some of the main ones I've dealt with over the years, probably the most common one is just water conveyance, right? Our culverts for our creeks, our streams, storm drain, just water conveyance. I think that's probably the first thing that comes to most people's mind for box culvert. Another one that I've done quite a bit is water storage or detention. This is really popular in the Pacific Northwest up in Oregon and Washington because land is so valuable and there's really nowhere to store stormwater effectively. And so they're putting them underneath parking garages, underneath parking lots, buildings, and it's just to store all of that water. So they're a great product for that as well, as you can see there. Pedestrian access tunnels. We have a few of these here in the state already. I know I believe Jason did a project spotlight of one down in St. George of a pedestrian tunnel. I know we've done a few golf cart pedestrian tunnels as well. Utility tunnels. Maybe you have to run multiple utility lines, and it would be a lot easier to group them all in some kind of box culvert or trench. That's another word you could use for smaller box culvert is trenching. But we've actually done some where it was on a mountainside, and because you have to separate your sewer and your utilities and your water so far, they could not do it because it was running up a mountainside. So the city said, if you'll put it all in a box culvert, you can put them all together so we have access to each one of them for service. Wildlife underpass. This one's just kind of a funny picture, but we've actually done quite a few wildlife underpasses. Some deer undercrossing, an elk. We did actually an antelope overpass up by Jackson Hole because they learned that antelope will not go underneath into a tunnel, and so they actually built the box culvert or the bridge for the traffic to drive under, which allowed the antelope to walk over. So this is actually a pretty popular use form as well. And then the last one that I've kind of dealt with is an air return system. At the very end, if we have time, I'll go a little more in detail on this job, but this box culvert was used for pretty much just an air return in a very large auditorium. So there's all sorts of good uses for box culverts that you can get really creative. Okay, let's go into a little bit of box culvert terminology. Might be basic for some of you, but I think it's important to know what you're talking about when you talk to people. The obvious ones are your top slab, bottom slab, your lay length. You can kind of see that's off going in an isometric view. I don't have the lay length in there, but the lay length would be the length of the box culvert. And then most importantly, when we call out a box culvert, we should always call it out as span by rise. So when you call out a box culvert, you would call this out as a 12 by 4 box culvert if it was a 12-foot span by 4-foot rise. Now I would say over all the culverts I've done, probably 99% of them, the span is larger than the rise, or at least equivalent. And so it's usually not that big of a deal, but every now and then I have seen where the rise is slightly larger, and usually I'd say that's when it does deal with pedestrian access. So maybe it's an 8-foot rise by 6-foot span. So you do not want to call that out as an 8 by 6 because that could be really confusing to manufacturers and designers. So just try and always remember, you want to call the span out first and then the rise. Now a haunch. We use haunches in precast box culverts for just to help with the structural integrity. It gives you some rigidity in the corners. And also we use them because it helps make a better product for quality and aesthetics. Our forming has haunches and it allows the product to be able to strip easier. So how do you call out a haunch? So what does it, if somebody says we have a 12-inch haunch with our form, what does that mean? Does that mean that their diagonal dimension is 12 inches? Actually, no, that does not. When calling out a haunch, it would be the horizontal and vertical dimensions. So if a manufacturer tells you we have a 12-inch haunch on our form, that would mean that it's a 12-inch by 12-inch horizontal by vertical area. Now, we can build box culverts without haunches, but we would prefer not to. It's a lot harder on the design, and it takes a little more with the forming and the manufacturing, so it can be done if there's an absolute critical reason that you do not want them in your culvert. But for the most part, usually it's not a big deal, and most people are okay to have haunches. A little more terminology, pretty basic, but the mel joint on a box culvert, you could call it a tongue or a spigot. It's a lot like reinforced concrete pipe. So the male end is the tongue or the spigot, and the female side would be the groove or the bell. So again, pretty basic, but good to know. Okay, types of box culvert. There's actually quite a few types of box culvert. The most common one is what we would call a monolithic four-sided. And we call it monolithic because that means the entire box is poured in one single pour. It's monolithically poured. And this is the most common. I would say, I don't know, 85% of the culverts I've dealt with over the years are this monolithic four-sided. Another pretty common stuff, well, I don't know if I'd call it common, but it's becoming more and more common, is this split culvert style where it's a bottom half, top half. And this is becoming a little more popular because of the size restrictions, and jobs are getting bigger and bigger. I would say in general, projects that I'm seeing, whether it's box culverts, whether it's vaults, whether it's pipe, manhole, whatever the product, everything just seems to be getting bigger. And so when you get bigger, you start worrying and thinking about, how do we transport these sections, and how do we lift them, and how do we install them? So you can imagine, I think I mentioned at the start that I've done as large as a 28 by 20 box culvert. You could imagine a 28-foot span by 20-foot tall box culvert. I don't even know how you would ship that. You try and lay it down and be 23 feet wide. If you stand it up, you're obviously way too tall. So you can cut this in half and have the joint right in the middle and stack them on top of each other for a larger culvert. We've done 2 or 3 of these actually for UDOT just here in the recent past, and they've really been successful. And then there's 2 other styles of split box culvert, not quite as common, where you have just the base section with a lid or the top section with a floor. I've seen a few of these. The base section with a lid is a little more popular. I know the Forest Service really likes these, especially again up in the Pacific Northwest, because they can put the base section in and then they can easily go back in and do all their stream work and stream restoration and then put the lid on later. I've also, on the top section and floor, that's probably the least common I've ever seen, but we did do one of those, and that was for a utility pedestrian tunnel, and that was because they wanted to do a cast in place floor so that it was one long smooth floor with no joints for where people were walking, and then they put the upside down U-shaped top on later. So those are options, and both manufacturers with Mountain States can do pretty much any of those options. But as you're thinking about your project and whether or not you should use a box culvert or not, there are a lot of possibilities there with sizes. Okay, I wanted to talk a little bit about hydraulics of box culverts also. The hydraulics, when you think about hydraulics, you have to use your Manning's roughness coefficient. And for precast concrete in the lab, we get a coefficient of 0.010 a lot of times, because that's perfect conditions. Everything is installed perfectly, or you're just looking at one section. But a lot of the testing we've done and ACPA has done, we see a coefficient of 0.010. With that being said, for precast, we recommend using in your design a 0.012, just to be conservative and make sure you're okay with the hydraulics you need. Now, a cast in place concrete, someone might ask, I've seen a lot of concrete callouts in books at as high as 0.015. Why are you guys lower, and why are you seeing better results? And I think the quick, easy answer to that is, cast in place concrete, typically speaking, isn't quite as smooth as precast. And that's because we're using still forms that are designed for exactly what we're doing, compared to a cast in place structure might be using just custom paneling forms. It's relying on guys that are doing an actual hard finish. And so they recommend a little bit higher for cast in place concrete. Now, a little story I will tell you about this exact thing. I was involved with the design of it was called Lamolo Hydroelectric Power Plant, and it was over in Oregon. And we were designing a pipeline to go from the main, to take water from the main power station down to the main river to help them with their power. And I was working with the local design engineering team, and we talked all about this, the 0.010, the 0.012, what's the best thing to use? And they really wanted to make sure they were covered. So they went super, super conservative, and they went ahead and went with the 0.015. Now, it was large diameter pipe. It was half the project was 96-inch diameter and half was 108-inch diameter. And after they installed it, we went back for the 1-year walkthrough, and they had their high water that year. They put all the water through that they were ever going to put through for a year, and the water line mark was only about 75% up the pipeline. And they kind of just laughed at it and said, yeah, well, we know we have plenty of capacity, but we probably should have used a lot lower coefficient, and we could have got away with a little bit smaller pipeline. And some of that is because on that large diameter pipe, a lot of times we will use SCC concrete, which gives just an absolute smooth glass type finish. It's that wet cast concrete compared to the dry cast. If people are familiar with that, we use both the dry cast and the wet cast. And so it probably is closer to the 0.010, if not even lower, but just kind of a funny side story there. This is kind of a busy slide. I try not to do slides that are too busy, but I'd like to just compare and show, because a lot of times we'll use Box Culvert, maybe because one of the reasons is because you do not have enough headroom from invert a flow line to where the top of your road needs to be. And so this is just kind of a comparison. If you look at the top row there, the pipe flow for a 5x3 box culvert is roughly 54 cubic feet per second, compared to the pipe flow for a 48-inch RCP is a little less at 49 cubic feet per second. So when you compare those two, that middle column that says total rise, the amount from invert to top of structure, you can see the box culvert is 3'8" compared to the pipe would be 4.45 feet. And then in addition to that, all pipelines require some sort of cover over top of the pipe. Flexible pipe a lot of time will require, I think, 1 or 2 feet minimum. RCP, the basic and suggested is 1 foot of cover. Now we can design for less than that. So those numbers don't account for fill on top of the structure either. This is just from invert to top of structure. And with a box culvert, you actually can have the box culvert top be the driving surface. And we're actually working with UDOT on a project right now where they're having our box culvert top. I believe it's coming out to bid, or it just came out to bid, but the box culvert top will be the driving surface, and they will be tying their roadway into the box culvert on the side. So you can see how much headroom and how much more advantage you can have with a box culvert. And you can kind of look at those real quick. We don't need to go over all of them, but in comparison, the bigger you get, like the 8x5, you're just over 5.5 feet compared to an equivalent RCP is more than 2 feet greater plus the potential cover. So that's one of the biggest benefits, I would say, of box culvert over RCP, is the fact that you can go a lot wider and you don't need the headroom. Jason, I don't know if you have any other thoughts or comments on some really good benefits of box culvert over pipe, but that's the main one I can think of.
I think you're spot on. Absolutely.
Okay, so that kind of gets into, people might ask, so what size of box culverts do you guys do? So when talking about, if you remember the monolithic four-sided, ASTM has some tables which we'll get to here in just a minute, but they have design charts that go from 3x2 up to 12x12. As mentioned, we can go larger depending on the manufacturer and the forming and your application. And so when all else fails, you can always just reach out to us and talk to us about it. But typically speaking, 3x2 to 12x12 is in the specifications. And I know I've talked to Oldcastle and I know what Geneva's potentials are. I would say a good rule of thumb for both of us is if you add the span and the rise together, you should try and keep it at about 30 feet or less. And if you can do that, we probably can do it in a monolithic four-sided box culvert. Now, obviously, tell me, hey, can I do a 30 foot or 29 foot by 1 foot? I'm gonna tell you, no, that's not realistic. So you can't just always say 30 foot is the absolute rule of thumb, but it's a very, very good starting point if you don't know otherwise. And then the other things you have to think about and look at when thinking about sizing is, how are we going to ship it? How are we going to handle it? Where is this project going? Is it realistic to have a 60,000 pound structure being installed underneath power lines? So there's just a lot of things to look at when looking at sizing. But in general, that gives you a good rule of thumb to start with. So now talking about specifications, kind of the history of box culvert specifications started with AASHTO and ASTM. So for the most part, the ASTM specifications and AASHTO specifications, they pretty much mirror each other. And a lot of the AASHTO specifications actually refer to ASTM. And I know there's a few of them that say, you know, refer to ASTM C850 for the most up-to-date design, because I believe ASTM updates a little more frequently than AASHTO, but for the most part, they go hand in hand. And the first two main specs that came out for precast box culverts are the C850 and C789 and the corresponding AASHTOs. And what they had there was, one was for box culverts that had less than 2 feet of cover, and one was for box culverts greater than 2 feet of cover. And the main reason they did that, and it's still kind of true to today on how you design these, but in the initial phases of this, it's because when you hit that 2 feet of cover, it completely changes the way you distribute your live loads through the soil. Less than 2 feet of cover, you distribute the loads through the concrete lid or deck itself for the most part, and then above 2 feet of fill, you rely more on the backfill and the cover over the structure to distribute the wheel loads. So it's quite a bit different way to design. So they had two different specifications for that. Then they made ASTM C1433, and this had to do more with the AASHTO Lrfd code. I don't know who all has dealt with that or how long people have been designing, but I think the last time it was updated, I want to say 2012. I'm not sure. Do you remember, Jason? I want to say it was 2012 or 14-ish.
Yeah, I think it was 12 when that was updated.
Yeah, so they went away from Lrfd, which stands for load factor design. So everything they were doing is you put all your load factors onto the structure, and those load factors are set. You know, for a live load, we're going to put a 2.17 always forevermore. For dead loads, we're going to put, you know, a 1.5 I can't remember what it is, 3 or 6. It's kind of like ACI, if anyone uses ACI 318. There's a factor design, you design your structure, and it is what it is. And ASTM C1433 combined those two specifications, those older ones, using the Lrfd code, and it was all one encompassing ASTM specification for no matter what the cover of fill was. Well, then comes along the new Lrfd design code, which, man, they've mandated that to be the design code now for years. And to get any kind of funding nationally, I know you have to use the new Lrfd design code. And that now stands for load resistance factor design. And just the basics of that is you're not only putting load factors on your loads, but you're also putting factors on your resistance, your concrete design, your reinforcing design. And there are a lot more load cases that are kind of statistically driven. You know, when you want a maximum vertical load, you might put maximum vertical loads with minimum lateral loads to get that maximum vertical stress. Or when you're looking at the walls, you might put maximum lateral loads with minimum vertical to get that maximum potential stress on the walls. So it's a lot more detailed design code. And so ASTM came out with C1577. And so that is now the new specification that you should be calling out for box culverts. There's also one other one you saw, and oh, I'll back up. That C1577 and all those previous specifications were for the monolithic four-sided box culverts only. Now, when you get into what they call the segmental box culvert or the split culvert that we talked about a little bit ago, where you have like a top half, bottom half, that's a new specification. And that one's C1786, and that is the Lrfd design. So it would be the equivalent to the 1577, but for segmental box culverts or split box culverts. I call them split box culvert, the code calls them segmental, or the specification. So just kind of remember when you're designing or you're calling out specifications, just make sure, you know, that the right one is called out and that you understand what is needed there. And as always, you can reach out to your manufacturers to help with that and get the right specification. And then the last one that you kind of should always look or think about is the installation specification. There's an ASTM that helps you on how to install a box, the tolerances, what you should be doing, how you should be doing it, safety. So there's a lot of good resources right there for you. With that being said, let's look at the 1577 code for just a little bit more in depth, because as I mentioned, that's probably 90% of the culverts we deal with. And it's also the AASHTO Lrfd code. The one thing I really like that I like about the 1577 code or specification, it's a design and manufacturing specification both. Not all ASTMs hit both sides of the precast. Some of them are just manufacturing specifications of what you can and can't do in the facility. Some just tell you how you're supposed to design the structure per the Lrfd code or per ACI, or using different load factors or live loading. This is an all-encompassing specification that has both design and manufacturing. So it is a really good specification to use. And there's a lot on here. I'm not going to sit here and go through it. I just kind of wanted to highlight. If you look at just kind of some of the main bolded points here, it talks about joints and what you have to do for joints and joint sealant. It talks about, there's a manufacturing section that talks about your aggregates and your cement and how you cure the product and what your forms can and can't do. There's physical requirements. There's tolerances in your box culvert. It goes through the materials on your reinforcing that you can and can't use. And then the design part of it, there are design tables in there that are already given for typical box culvert sizes using the AASHTO code with an HL93 live load, that if you don't have maybe engineering, or you have a very simple project that fits the mold of these tables, you can use these tables, and it's already been designed and accepted nationally per the AASHTO Lrfd code. So when we look at those tables, what do they kind of look like? So on the left-hand side, that's the appendix. Again, don't try and read it all. Just wanted to show you there's an Appendix Nc 1577 that tells you all of the stuff they used to design the box culverts in C 1577. It tells you that the steel reinforcement is assumed to be a mesh reinforcing mat with a grade 65. It tells you that your concrete strength should be 5,000 PSI minimum. It talks about your soil data and what your minimum soil data loading should be. So you can kind of look at that and say, does my project meet all those requirements? And if it does, maybe I can use that table. If it doesn't meet those and the loading requirements are more than that, or it doesn't fit in that box, you can always do your own structural design, which that's what the manufacturers are here for. Both Oldcastle and Geneva, myself and Troy Banks with Oldcastle, we are registered PEs and we both design box culverts all the time. So it's something we do very, very easily and quickly. So then on the right-hand side, there's your chart. So as the charts go through, there's pages and pages of them. You'll see at the top, in this case, it calls out 8 foot by 4 foot by 8 inches. So we know that 8 foot by 4 foot is your span by your rise. That 8 inches, that's what the top, bottom, walls, and haunch thickness would have to be at a minimum. So that is saying you need an 8-inch top deck, an 8-inch bottom slab, 8-inch walls, and a minimum 8-inch haunch dimension. If you have that and you meet all the requirements and all the loadings in the appendix table, you can now use these reinforcing designs based on the design earth cover on the left-hand side there. And you'll see 0 to 2 feet. We talked about that being critical. 2 to 3 feet, 3 to 5, 10, 15, goes all the way up to 20 feet of fill. And it tells you what that design is. Now you might be saying, well, what are all those numbers? I see AS1, AS2, AS3, I see 0.27. I see all these numbers. What does that mean, Mike? Well, the numbers in the chart, that is your required circumferential reinforcing still area per foot. So that very first one, when you see AS1, 0 to 2 feet of fill, it calls out a 0.27. That means we need 0.27 square inches of reinforcing per foot of box culvert for your AS1. So pretty straightforward on what that is. Now you're going to ask, well, what is an AS1? That makes no sense. I've not done precast. I don't know what AS1 is. Sure enough, in C 1577, it has a detail and shows you what all these requirements are. And again, there are 2 requirements. There's fill height less than 2 feet, and there's suggested reinforcing, and then there's a fill height greater than 2 feet. The main difference between the 2, if you look at those for a minute, and I know it's busy, but if you look at it, the main difference is that we call it distribution still, or it's the still running the, what would it be, parallel to the creek. You can see less than 2 feet, they require that reinforcing, bottom distribution reinforcing in the deck, compared to at 2 feet or greater, they do not require that. Any ideas why that would be? Jason, do you have any thoughts of why we would have to put that in for less than 2 feet compared to not?
Yeah, I mean, you've got obviously much higher live loads, and so we want to make sure that we've got extra steel in there to accommodate that additional live load.
Exactly. Yep. When you don't have that fill, if you remember, I kind of talked about with less than 2 feet of fill, we rely on that concrete deck to transfer the loads through the structure. So how do you transfer a load running in and out of the page? If you're looking at the page, how would you transfer a load from bar to bar and distribute that load through the concrete if there's not reinforcing to do that? And so that's why it's required there. Whereas above 2 feet of fill, I mentioned the loading is distributed through that soil, and so you don't need it. You still have to have minimum reinforcing for temperature and shrinkage, but you don't need that extra amount. And so as you walk through this, you can see AS1 is the outside reinforcing that goes up into the corner. And for the most part, it's that corner still that's the most important because of the negative moments from the deck that the corner of the box culvert sees. And then AS2 is your bottom deck mat. That's probably your most critical, obviously, because that's your top slab. AS3 would be your bottom slab mat. AS4 is your 2 wall mats, 1 on each side. And then AS5 is that distribution still we talked about. It's in the bottom deck, or top deck, bottom mat. And they do show reinforcing bars there in the mirror of that, the top deck, top mat. That used to be called an AS6 bar. And they used to require that, and they did a lot of testing and found out that it pretty much was pointless. So they actually don't require that anymore. I'm kind of surprised they still show that in the charts. And then AS7 would be your top slab outside mat, and AS8 is your bottom slab outside mat. So it actually walks you through pretty good. If you were designing a little box culvert for something local and it kind of fit the vanilla box of all those things in the appendix, you could take a look at this and you could design a box culvert and be okay. Some of the main things we look at when doing box culvert designs, one, we look at the live loading. That's obviously really, really critical. I think that goes without saying. We've talked about the depth of fill over the box. That's really critical, as you've now seen. Soils reports are always nice to have. If you know what your soil conditions are so that you can get your soil weights and your lateral soil loading. Now, if you don't have a soils report, that's okay too. The AASHTO code tells you what to use and what to assume if you don't have one. And those values, they go a minimum lateral loading of 30 PCF and a maximum of 60. And those are fairly conservative. I would say all the UDOT projects I've worked on are more in the range of 35 to 55. So the minimum's a little higher and the maximum's a little lower. So they do give you values to use if you don't have a soils report. We want to know what the specification requirements are, right? Everything we've been talking about. And then another really critical thing is the direction of the live loading. Most box culverts or bridges, you would say, are parallel to the span. The traffic drives directly over the span. I would say that's the most common. Now it's becoming more and more common as we build more and more development out into further away, that we also start getting box culverts that are on what we call a skew. And that means the span is not parallel to the direction of what the traffic drives. That does a couple things. If you look at the right diagram there, the right picture, you can see that the wheel loads from that car are going to effectively be closer together across the span of that box culvert because that box culvert's been turned. So instead of, our HL93 live loading, you have an axle spacing of 16 feet. But if you start turning that box culvert, that axle to axle spacing effectively decreases. And so we have to look at that as designers and make sure that you're accounting for those wheel loads getting closer together. And then the other thing you have to look at is, what if I actually skew the end of a box culvert? If you could picture that we actually cut that box culvert on that left side, and you could picture that we're going to build it square on one side, but the other side is going to, I call it pie-shaped, or that structure is a trapezoidal type structure, your box culvert. Now you've changed the actual design span of the box, because you've taken a diagonal length on that box culvert, and instead of, let's say we have a 10-foot span culvert, but we're going to go 45 degrees and cut that box culvert, that span that it is spanning that box culvert now increases 45 degrees of 10-foot span. So you have to look at the design of what the actual effective span is and how the traffic is driving over it. I believe the code tells you if it's less than 15 degrees skew, you don't worry about the skew and you just ignore it as far as the traffic goes. I've always just used a rule of thumb. It's easier with the design programs we use. If it's above 30 degrees skew, I just go ahead and say that the traffic is running perpendicular, or that traffic literally is running straight on top of that box culvert, perpendicular to the span. And that's the most conservative, right? Because now your tire to tire load is only a 6-foot spacing, because you're looking at the 2 front tire loads compared to 2 axle loads. So I hope that makes sense. If it didn't, I'm sorry, you're more than welcome to reach out to me, but I guess the take home for that is if you have a skewed box culvert, just make sure we're designing them properly. I think with that being said, Jason, I think you have another poll question now, don't you?
Yeah, I do actually. Yep. Let's go ahead and launch one here. We're curious, and I might do both of these together because they're kind of similar. So I've got 2 questions here. We'll ask this first one. We want to know, for box culverts, when if you're speccing them, do you typically call out cast in place or precast? We want to know, is it mostly cast in place? Is about half cast in place, half precast, or mostly precast? So go ahead and vote on that. Let's see. All right, we've got about half of them voted, so we'll give you a little bit more here.
I'm realizing it's taking a little more time than I thought, so I'll try and scoot along a little bit.
So we're at we're about everybody voted, so I'm going to close this out here, and we'll see the results. And it's kind of what I was hoping to see. Let me share those with us. About 85% said mostly precast, so an overwhelming majority are mostly specifying precast, and so that's good. The next one, we wanted to know kind of what you're calling out on your plans. So do you mind if I launch that one too, Mike?
Absolutely. Yeah, perfect.
Okay, let's go ahead and launch it. While we're going, we may as well. So when you're calling out a precast box culvert on your project, do you typically perform all the structural calculations yourself? That's A. B, just call out the size and length and let the manufacturer design it. Both A and B. Or I don't spec precast box culverts. So if you don't spec precast box culverts, just go ahead and say I don't spec them. So about half have voted. We'll give about 10, 15 more seconds to let everybody cast their vote there. All right, maybe just a bit more, and this is exactly what I wanted to see. A lot of efficient engineers out here. I'm going to close it and share it. Look at that. 100%.
Oh, nice.
Call out the size and length and let the manufacturer design. You know, that's what we call in the business the law of conservation of energy. It isn't. My mom used to call it the law of least effort, but we call it the law of conservation of energy. Don't do more work than you have to. If we've got structural engineers that can do it, let us do it. So perfect. That's all I got for those polls there. Mike, so I'll turn it back over to you.
Awesome. That's great. That means we can kind of fly through this a little bit quicker and maybe get to some fun stuff. So since everybody does it properly, how should we detail and design a culvert? You guys all probably know this because you just said this is what you do. Contact your local manufacturers first and foremost. Call Geneva, call Oldcastle, get with us on what we can do, what we can't do, maybe what would be more expensive, less expensive, and let us help you design the most efficient culvert we can for your customer and client, and then they'll be really happy with you. Another really important thing, call out certified plants. If you do a design as an engineer and you make all these requirements and you don't have a plant that has a certified quality certification, your work as an engineer is almost invalid because you don't know you're getting what you asked for. So that's whether it's NPCA, ACPA, UDOT certified, whatever it is, make sure you're calling out a certified plant. Make sure you call out some specifications. What specifications do you want to use? Which, you know what, Jason, why don't you go ahead and just mention the specifications?
Absolutely. So we have a specification that we wrote. It's available to download on our website. This was written by members of the Mountain States Concrete Pipe Association. We all came together about 4 years ago and put together a precast box culvert specification that engineers can use. They can use parts of it, or they can use the whole thing. But basically, we wanted to come together and have it be consistent with what all of our manufacturers were doing, and make sure we could get the best product out there. So that is available to download on our website, mountainstates.concretepipe.org. If you go to that front page and scroll all the way down to the bottom, it says Box Culvert Specification or New Box Culvert Spec, and you can just download that. It's in a Word format, so you can copy and paste and take what you need. So feel free to grab that if you ever need it. If you forget where to find it or whatnot, shoot me an email, give me a call. I'd be happy to direct you to that specification.
Yeah, great. That's great. Require the proper design, that goes without saying, and just give the critical dimensions and details on your plans. And when I say critical dimensions, obviously the span and the rise are critical, but don't worry about what wall thicknesses to call out unless there's something critical. Maybe you do have a critical dimension from invert to roadway, and so you want your top slab to be a certain dimension, so you might call it out there. Or maybe you absolutely cannot have a haunch or a maximum size haunch just for hydraulic reasons, but don't overdo it. Like Jason said, keep it simple, take off the hassle for yourself. And here's just an example of even a UDOT one. As you can see, there is a lot going on, but when you look at the precast itself, they call out the span, the rise, the total length of the culvert, and not much more. There's no reinforcing design. There's no sections called out where they've broken up and to show that it's precast every 8 foot or 6 foot. Just draw a generic drawing and let the precaster do the design, and call out that the precaster has to provide a stamp design. And then it takes a lot of the liability off of you, which is great. So here's what a typical precast submittal might look like. Just a quick plan view layout. We'll break it out section to section. We label each section. We tell you where to start, how to pull, how to install it, the flow direction. So we'll give pretty detailed submittals to help you out. Okay, installation. This one is really, really critical. One of the most important parts after we have built our culverts is to make sure your foundation is proper. If you have a unlevel, uneven foundation, you are going to have problems with point loading. You're going to have gaps because culverts don't come together because maybe the back end of it is a little lower than the front end. And the most successful culvert projects I've seen installed are when we require a leveling course. And I believe we call out for a 2-inch leveling course. So
and
this
that
quick
is
little
included in the specification that we wrote, Mike. So
yes. Oh, great. Thank you, Jason. Yeah. So if you have a good base material under it, sure, you can go ahead and use that base material under it, no big deal. But if it's not a good material, you might want to over excavate 6 to 12 inches and get a good granular material in there. But for the final grade, it sure helps to have a couple inches of a pea gravel or a just something that can be raked and leveled easily. But every single successful project, here's a couple more good pictures you can see, they're screeding it almost like as if it was concrete, that top layer. And then you get a much more even surface to put your precast on. Both of those are UDOT projects, and both of those they screeded and leveled, and the projects went really good. I'd say the sections were going together within 1/8 of an inch for the most parts. So it's super, super critical. I can't emphasize more. Make sure that grade is set properly. Now, how do you install a box culvert? So you would want to start downstream, and you put your first piece in, and if you remember, it would have that female groove there on the right. And then you want to lower down in the male end, lower it into the hole and pull it into the male inside the spigot into the groove. And so you're installing left to right, and typically your flow would then be right to left. Now that flow being right to left, not only is that good because you're installing downhill and you'd rather pull boxes downhill than try and pull a box uphill. But if you look at those joints, it just makes sense to have the flow going from right to left. If you can picture water going over top of that spigot or tongue and over top of that next groove compared to if you took flow the opposite way, it would kind of, in my mind, want to be hitting that spigot and going into the joint more. So for so many reasons, it just makes sense to start at the bottom, start with your groove piece, and pull your spigot or tongue piece into that groove. Now, how do we help you do that as a contractor? Both suppliers, both manufacturers put little pulling anchors in the walls, and you can hook a come along up to that or some pulling chains, and you pull the boxes together. Now, the best way to do that is to have the crane, or however they're lifting that box culvert, they're gonna hold roughly, oh, I don't know, 80, 90% of that weight. If you can get it to where you're not picking it up, but you are picking it up, if that makes sense, if you could somehow pick it up a 30/2 of an inch, that would be perfect. Because now the weight is off, your joints are aligned, and you can suck those precast sections in together. Works really, really good, and I know both manufacturers do that. So end of the day, really quick, we'll wrap up. Why precast? First of all, we build all of our products in a quality controlled environment. Nice buildings that are warm. We're not dealing with the elements in the winter. We're not dealing with the elements in the summer as much if it's out in the field. And the product is pre-approved before it goes out to the site. So if we have a problem, it's not a shutdown of a road for an extra month because we have to redo something. We've already approved the product before it ever gets on site. National design standards and manufacturer design liabilities. As you guys have seen, there's already national standards with the AASHTO code and the ASTM specs. They're used every day all over the country. And then the manufacturing design liability. You don't have to design it as an engineer. You don't have to try and figure out how the heck do I design a cast in place box culvert. I got to go back to my 101 concrete class in college. I hope I caught everything. It's going to take me all week to design this thing. Put all the liability on the manufacturers. Speed and ease of installation. These box culverts go in so fast. I've seen anywhere, I'd say on average, you can get at least 25 feet an hour of box culvert put in. And I've seen as much as 50 feet an hour, depending on how quick and good the crews are and the way the foundation is prepped. So why is that a good thing? Well, obviously, the shorter you can keep roads closed, the less impact we have to the community. It just, time is money, right? Nowadays, everything is quicker, quicker, quicker. Be done faster. Why is the road closed? Jason, I think you've had some experience as I believe as a city engineer, right? Dealing with people being mad about closures.
Oh yeah.
So,
There's a lot. I know there was a project that we did on 7200 South, a major roadway that, it was going to be open. It was going to be closed for almost 2 months, but they were able to get the thing done. I think in 2 weekends. They opened it up, got half of it put in, closed it, opened it up the next weekend, and so instead of 8 weeks of calls and complaints, it was they got it done in like 2 weekends. So that's a pretty big deal there.
Yeah, time is money now. And then kind of the last comment I'll make is versatility of what we can do. Because we have facilities and because we have the time, we can take the time to do some pretty custom things. We can do some pretty cool things that would be really hard to do in the field and would take a lot of time. Yes, it might cost money, it might take a little bit longer, but if you plan properly and you work with the manufacturers on what makes sense, we can do some pretty awesome things. It looks like we have about 5 minutes. Maybe that was it for now. I do have some projects that are really cool, but I don't know if we have time or not. Jason? There any questions, Jason, that anyone asked that maybe we should hit before I quickly just show a few unique jobs?
No, just a reminder that we do have. I will be sending out PDH certificates. I apologize. My account got blocked for the last couple of weeks, and so I wasn't able to download the attendance report from last month. So those of you who attended last month, I will send those out next week with the PDH for this, because I can finally access those numbers from last month. For whatever reason, I couldn't access them, and so they've got it all fixed for me. So I've got that. So these will be coming out next week. But yeah. That's the only real question we have. So go ahead and if you do have questions, type them in. If not, take a couple minutes and show some of these cool projects, Mike.
Yeah, these are all projects I've been involved with, and I just wanted to show some of the you know, some of the versatility of what we can do. And you might not have thought to do a box culvert. I don't have pictures for all of them, but I at least should have, let's see. So this is one that we're working on with UDOT. It's not been installed yet. I think it's installing this December, but you can see it's a pretty massive. It's a double cell 26 by 17 inside dimension box culvert. So it was the split culvert. It's out kind of by Monticello, out in the middle of nowhere. So another unique thing, other than obviously the massive size of this, they cannot get any concrete out there in any kind of reasonable, efficient manner. So these wing walls, you can see the wing walls there in the corner, they're as tall as 25 feet tall. That typically does not lend itself towards precast. But I worked with the design engineer in UDOT and with the GeoGrid company. I don't know if anyone's familiar with GeoGrid, but we're casting GeoGrid into the back of these wing walls, and they're essentially tall MSE walls. So even though we're precasting them, they're gonna be able to install these and not cast them in place by using GeoGrid tieback. So that was kind of cool. Here's one we did, I-15 climbing lanes, just a big one. We installed this, it was for UDOT. It was down there by, what's that fort down there north of Beaver called? I can never remember.
Cove Fort, is that Cove Fort?
Fort, yes,
Cove.
Thank you, Cove Fort, thank you, Jason.
Yeah.
The kind of the nice thing of this that we can show you, it was 3 phases. If you look up there on the right, phase 1 was the first section. Because of the way they had to shut the roads down, that's a major road up there, a major highway. So they did phase 1, and then phase 2 was the 2 sections of the middle, and then phase 3. So they essentially didn't really shut the roads down for the most part. They limited them, but they never shut them down completely. And again, you can see a 24 by 12. Again, pretty darn big culvert. This one was one I did a long time ago. BYU Idaho, up there in Rexburg, Idaho, built an auditorium of, I want to say it's like a 20,000 student auditorium. And they were trying to figure out how to do their air return ducts underneath the stadium. And we come up with 10 by 7 and 8 by 7 box culverts that went underneath this massive auditorium as air return. It's basically just for air return. So these are all box culverts that veer off. They're going up on a slope, because if you can picture an auditorium, I have some picture of this actually. So big, huge box culverts that come into these massive junction boxes. And that bottom right picture, you can see 2 holes in every culvert on each side for air return duct, an 8-inch air return. So that was just a utility air return. And if they would have had to cast that in place, can you imagine? I mean, look at this. If you cast that in place, that would have taken, oh man, 6 months maybe. And they installed this, I want to say they installed this in a week. So pretty cool there.
Hey, before you move on to the next one, Mike, I do have a question that came in, a couple of questions.
Oh, great.
One of them was, what about precast wing walls or end sections? Yes, we can do those as well, right? I mean, that's usually not a problem. We could put those in, and they'll cast and go right up next to it. And so I think that's what they were asking, is if that's a capability, if we can do it precast, and the answer is yes, we can. The other question was, for the haunches, is there ever a case where the vertical haunch wouldn't be equal? Or excuse me, is there ever a case where the haunch wouldn't be equal in both the vertical and horizontal directions? You said like a 12-inch haunch is 12 inches on the rise, 12 inches on the span, but is there ever a case where your haunch is not the same in both directions?
For our purpose, from the manufacturer and design side of it, no, we would never want to do that.
Right.
If for some reason you need that for some really awkward, weird, specific reason, you know, we can look at it, and there could be a potential that we could do it. But from our end, we would rather not do it.
Right. Looks like you brought up the first picture there where it shows some precast end sections and wing walls there, and cutoff wall there. So yeah, great example of what we can do precast.
Yep, that last box culvert piece there was attached to that head wall and wing wall. That was all one section. And I know both manufacturers can do that. So yes, that's a good question, but there was a good picture for that.
So those are all the questions we had, and I think that's about all the time we've got, Mike. We're on the hour. So do you have one more that you want? I know you showed this snake one. Let's show this one. This is a cool project. So we'll do this one and then be done.
Last one. So this one's up in Jackson Hole, and it's at the base of Snow King Resort. And a developer wanted to build a bunch of condos up on the mountain, and the city told him he had to build a road, but it could not be a visible road because it's Jackson Hole. That's ugly, right? So we had to build a 26 by 15 foot long, 600 foot, or 26 by 15 by 600 foot long drive tunnel that snaked, as you see it here, this is plan view, snaked as it went up the mountain. And so here's kind of some pictures. That bottom left one, you can see the Snow King Resort there. The entryway into that drive tunnel, it was a 2-lane road. And then that top right picture is where it starts to make that first curve. But that was a pretty unique, pretty awesome project. Just kind of, again, displaying what we can do with precast. And again, it was installed in, I believe, 2 weeks compared to, oh my goodness, there was 70 feet of fill on this in some points. So, I mean, that would have taken months.
That's an awesome project. That's cool.
So that's all I have.
All right.
Reach out to Jason or I, and I appreciate it, Jason.
Yeah, absolutely. Thank you, Mike. Again, great presentation, great information there. Well worth the time. So I appreciate you doing that. Remember to check our website. Next month, Mike and I will be doing a presentation together for the December one. We're going to be talking about repairing pipes and patching pipes and things. So that's going to be a good presentation. So thank you again, everybody. We appreciate it, and have a happy and safe weekend.
Thank you, everyone. Bye.